All right, so with the homework, there's a few of them that I want to go over with you guys just to extra practice some of these. My numbers are different than all of yours. Everybody has different values, but it's going to be like the same type of question. So it'll be the same process working it out. It'll just be different numbers that you have, so your answer may be a little bit different. So looking at number 3. So the graph shows the right hand and left hand behavior of a polynomial function f. Can the leading coefficient of f be negative? What do you think? No. Why do you think no? Because the right side's going up, so that means it has to be positive. So this is nope. Has to be positive. Because remember, if it's positive, the right arrow will always go up. If it's negative, the right arrow will go down. So we have to match the polynomial function with their graphs. So looking at A, I have negative 2x plus 3. Which term do I look at to help me determine the end behavior? For A, I look at negative 2x because I look at the highest degree. So this is, what degree? Is it even or odd? It's odd. So are they going to go in the same direction or opposite directions? So they go in opposite directions. Is it positive or negative? It's negative. So what's my right arrow going to do? Right arrow goes down, and the left arrow? Left arrow goes up. I can match that with my graph. I have a couple options here. I have this one where the right arrow goes down, left one goes up, and so same with 6. But looking at this type of equation, negative 2x plus 3, what does this look like? It looks linear. It looks like y equals mx plus b. So which one do you think it's going to be? 6. So we used 6. I can cross that one off. Let's look at b. Here I have x squared minus 4x. So which term here am I supposed to look at to determine the end behavior? The x squared. So is it even or odd? Even. So are they going to go in the same direction or opposite directions? Even means same. And is it positive or negative? Positive. So is the right arrow going to go up or down? Right arrow goes up. What about the left one? Up. So looking at my graphs, which one do I have that both arrows go up and up? 8 and 7. So I have 2 options here. Let's look at my graphs and see the difference between them. They both go through 0, 0. But 7 has a different x-intercept that kind of looks like 4. Right? Or no, this would be negative 5, so this is negative 2. Negative 2, 0. So if I plug in negative 2 into my equation, I should get 0. So let's see if that works. So we're testing out 7 to see if that works. So I have negative 2 squared minus 4 times negative 2. This would be 4 minus 8 plus 8. 4 plus 8, which is 12. So when I plugged in negative 2, I didn't get 0, I got 12, which is more like 8. So let's look at C. Which term am I looking at here? Negative 2x squared. Is it even or odd? It's even, so same direction or opposite direction? Same. Is it positive or negative? Negative. So what's the right arrow going to do? And what's the left one going to do? Down. Since it's even, they go in the same direction, so it's down and down. So looking at our graphs, which one goes down and down? 3 and 5. So I can pick a point on 3 or 5 and test that and see if it works in my equation. So I kind of want to look at my graphs and see where I would have a whole number. They both go through 0, 0, so I couldn't just plug in 0. But I guess for this one, I could plug in -1. That could kind of give me an idea. So I have -2 times -1 squared minus 5 times -1. So this would be -2 plus 5, which is 3. So looking at my graph, if I go to -1, 3, that would be here, which is kind of close, so it's a little bit hard to tell on 5. But -1, 3 is right on 3. I could test another point just to check. So if I plugged in something like +1 and +1, if I plug it in this one, I should get about like 2. If I plug in +1 there, I'll get like a bigger negative number, or I guess smaller negative number. So let's plug in +1 and we can see. Because we're not 100% certain when we plug in -1. So if I plug in +1, I have -2 times 1 squared minus 5 times 1. So -2 minus 5 would be -7, which means that it has to be 3, because that would be off of our graph down here. -7 would be here, which is not on our graph. So we would say 3. If I can cross that one off. So for these, it's kind of just process of elimination. Now that I eliminated some that are similar, so looking at number 10, it says, consider the following function, find the zeros algebraically, and then we need to graph it. How do I find the zeros? We factor. How can I factor this? What should I do first? Perfect. We're going to take out a 5, so I'm going to divide all of these by 5. And then I'm left with x squared minus 2x minus 1. Now let's see. Do I have two factors of -1 that add to -2? What's -1 times -1? So do I have two factors? What do I do if I don't have factors? Quadratic formula. So our quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. So this would be my a, -2 is my b, and -1 is my c. So I'm going to plug everything in. I have -2 plus or minus the square root of -2 squared minus 4 times 1 times -1 over 2 times 1. And then from here we simplify. So that -2 will become a +2, plus or minus. I'm going to simplify everything on the inside. So -2 squared would be 4. -4 times -1 would be +4. And then 2 times 1 is 2. And I can go ahead and simplify the inside too. 4 plus 4 would be 8. If you can simplify it, you have to simplify it. So can I simplify this anymore?
Could you cancel out the 2's?
Can I cancel out the 2's? What do we think? No, I can't unless this was also divisible by 2. If I had a whole number 2 here, then we could. It has to go into both things on top, but it can't just cancel out with the 1, with the 2 that's already there. But can I simplify the square root of 8? What are two factors of 8? 4 and 2, and two factors of 4? 2 times 2. So I would circle any pairs that I have, and that comes to the outside, and whatever is not circled stays on the inside. So this is 2 plus or minus 2 square root 2 over 2. Now can I simplify this? Yes, how? Does it just cancel? I'm going to divide everything by 2, and what am I left with? Perfect. 1 plus or minus square root 2. So I divide everything by 2. This turns into 1 plus or minus square root 2. So our zeros would be 1 plus square root 2, comma 1 minus square root 2, because there's 2 of them there. So it says use a graphing utility to graph the function. In your calculator, you could find out what the value is of 1 plus square root 2 and plot that on your graph. And then 1 minus square root 2. Also, I think it should be the last one, D. So you could just plug these two values into your calculator and find out where those x-intercepts are. Because those are the values where we cross the x-axis. So it's a little bit harder to see when you're adding a square root, but you could put that value into a calculator. And you'll see this one ends up being like 2.2 probably, and the other one ends up being like negative, a small negative. All right, so looking at number 13. First thing I want to do is factor it to find my zeros. How can I factor this? Take out a 2. So now I'm left with x to the 4th power plus, this would be 3x squared plus 2. Do I have two factors of 2 that add to 3? 2 and 1. So how would I write that in my parentheses? Be careful because we start with an x to the 4th power. So it'd be x squared plus 2 and x squared plus 1. Now again, how could I find the zeros? I just factored it, so I'm not done yet. How would I find the zeros? Set them both equal to 0. So they both get set equal to 0. So 0 is equal to x squared plus 2, and 0 is equal to x squared plus 1. I'm going to solve for x in my first one, so subtract 2 on both sides. Negative 2 is equal to x squared. What should I do next? Square root it. Can I take the square root of negative 2? No, so is this a real 0? No. So I could stop here. It's not a real 0. I'm only finding the real zeros here. Let's look at the next one. I'm going to subtract 1 on both sides. So I have negative 1 is equal to x squared. Take the square root. Can I take the square root of negative 1? No. So do I have any real zeros here? Nope. So this would be does not exist. We don't have any real zeros. So what do you think my graph looks like? Does it touch the x-axis? No, I don't have any zeros, so it's not going to cross the x-axis. So when you don't have any real zeros, you don't cross the x-axis. So let's look at 17. So we have to find all the real zeros and determine the multiplicity of each zero. So how would I find the real zeros here? What do I need to do? Set it equal to 0 and then do what? I want to factor it. So I'm going to factor out the x squared. So then I'm left with x squared minus x minus 6. And then we want to factor it even more. So what are two factors of negative 6 that add to negative 1? Negative 3 and 2. So in my parentheses, I have x minus 3 and x plus 2. And outside, I can't forget I still have that x squared. This is 17. What do I do from here? Set each one equal to 0. So I have x squared is equal to 0, x minus 3 equals 0, and x plus 2 equals 0. So x is equal to 0. for that x squared is equal to 0, because I would just take the square root of both sides. Square root of 0 is 0. What's my other 0 here? What I saw. Perfect. X equals 3. And then my third one? Negative 2. So at 0, do I have multiplicity here? Yes, because x squared was equal to 0, I have two x's that equal 0, so I have a multiplicity of 2 at 0. What about for x is equal to 3? Do I have multiplicity here? Multiplicity of 1, because I only have one of them. And then at negative 2, multiplicity of 1. So 20 is the one where we have to work backwards. We're given the zeros and we have to come up with the polynomial. So how would I start? Anybody remember from Friday? Awesome. We changed the sign, so it's x minus 3, x plus 5, x minus 5. And then what do I do for just the 0? It's just an x. Perfect. Because it would be like x minus 0, but we don't put x minus 0. It would just be x. What should I do next? Foil it out. I'm going to work with the 5s first because I see that they're conjugates of each other. So I know the middle parts will end up canceling out. So that's why I'm going to pick these two first. It doesn't matter the order that you multiply them in. I just know that it'll be easier when you work with conjugates first because the middles will cancel. So start with the first terms. X times x would be x squared. The outsides would be negative 5x. Insides would be plus 5x. And then the last ones would be minus 25. So that minus 5x and plus 5x cancel. So this is just x squared minus 25. What do I have to do next? Perfect. I'm going to FOIL that with x minus 3. So I'm just multiplying these two together now. So the first terms would be x times x squared, so that's x to the third power. X times negative 25 would be negative 25x. Negative 3 times x squared would be negative 3x squared. And negative 3 times negative 25 would be positive 75. And then I still have another x, but I can just distribute that to everything on the inside. So this becomes x to the fourth power, negative 25x squared minus 3x to the third power plus 75. What do I have to do next? Awesome. I want it to be in standard form. WebAssign especially will want it to be in standard form. So we just have to make sure that our terms go in order. So I start with x to the fourth power minus 3x to the third power minus 25x squared plus 75. And then we have to name it with that f of x. WebAssign already gives you the f of x equals, so you don't have to type it in on WebAssign. But on a test or quiz, you'll have to put it. Yes? Yeah, because we distribute the x there. So it should be 75x. Thank you. So for 21, my two terms are 1 plus square root 3 and 1 minus square root 3. These are my zeros. So what do I do to find the polynomial? Perfect. X minus 1 plus square root 3. And then x minus 1 minus square root 3. What do I have to do next? Distribute. I want to distribute that negative. So I have x minus 1 minus square root 3. And then x minus 1 plus square root 3, because when you distribute the negative here, it becomes a plus. So we could FOIL this out, just make sure everything in your first parentheses gets multiplied to everything in the second, but I'm going to show you a shortcut. So I briefly mentioned this on Friday, but we kind of ran out of time. So our first term is going to be this x minus 1, because it's the same in both of them. Our second term is square root 3. Because these are conjugates of each other, one of them is x minus 1 minus square root 3, the other one's x minus 1 plus square root 3, I can do the shortcut. So the shortcut is we square the first term, so that would be x minus 1 squared, minus the second term squared, so square root 3 squared. So again, you could FOIL it out. It's just going to be a lot more work because you have 6 terms, so everything in the first parentheses would have to get multiplied to everything in the second. But instead we can use the shortcut because these are conjugates of each other. So what do I have to do for x minus 1 squared? I have to FOIL that. So this is like saying x minus 1 times x minus 1. I have to FOIL it, so it'll be x squared minus x plus 1, which when I simplify, it'll be x squared minus 2x plus 1. And then what happens to the square root 3 squared? It becomes 3. The square root and the squared cancel, so this is just minus 3. What should I do next? Combine like terms. So this would be x squared minus 2x, and then 1 minus 3 would be negative 2. And that would be my function.